In this video, we will try to solve these three problems. I recommend that you watch all the videos in this playlist from the beginning so that you can apply the sum and difference formula of all the trigonometric functions. If you already know how to solve this, please pause and give it a try yourself. You can come back and watch the solution. So let's try the first one now. So in the first question, we have to prove that cos of 7 pi by 12 plus cos of pi by 12 is equal to sine of 5 pi by 12 minus sine of pi by 12. So to approach this, let us change these values to degrees. So the first one would be cos of 105 plus cos of 15, and this can be changed to cos of 90 degrees plus 15 degrees plus cos of 90 degrees minus 75 degrees. So this is of the format cos of pi by 2 plus 15. So pi by 2 plus 15 degrees, this is the second quadrant, and in second quadrant cos and secant both are negative. So this will change to minus sine of 15 degrees plus, now this is 90 minus 75, so this is first quadrant. So when it is first quadrant, cos is positive, so this will be sine of 75 degrees. So this is nothing but minus sine of pi by 12, 15 degrees is pi by 12, plus sine of 5 pi by 12. So that is how we can prove that the question is also equal to sine of 5 pi by 12 minus sine of pi by 12. Let's try the second one now. So here we have to prove that tan A plus tan B divided by tan A minus tan B is equal to sine of A plus B divided by sine of A minus B. So here we can change tan to sine A by cos A plus and tan B to sine B by cos B divided by sine A by cos A minus sine B by cos B. Now let's solve for the common denominator. So the numerator would change to sine A times cos B. So I'm just cross multiplying the denominators here, plus sine B plus cos A divided by cos A cos B, and then the denominator, when we solve it, we would get sine A cos B minus sine B cos A divided by cos A cos B. Now we can cancel out cos A and cos B. Now if you observe, this is of the format sine A cos B plus cos A sin B, which is sine of A plus B, the numerator, and the denominator is of the format sine of A minus B. So please memorize those formulas which we had discussed in our formula sheet. It will be very useful to you when solving these questions. Let's try this third one now. So in the third one, we have to prove that cos of 9 degrees plus sine of 9 degrees divided by cos of 9 degrees minus sine of 9 degrees is equal to tan of 54 degrees. So the question has cos and sine, but the proof that we want to achieve is tan. So to get tan, we can divide the numerator and denominator with cos of 9 degrees. So we are going to divide it by 9 degrees. So what will happen is, so this will be cos of 9 degrees by cos of 9 degrees plus sine of 9 degrees by cos of 9 degrees, and the denominator would be cos 9 degree by cos 9 degree minus sine 9 degree by sine 9 degree. So this will cancel out. So basically we would have 1 plus tan 9 degree and 1 minus tan 9 degree. Now you might wonder, like, how do we get to the point of 54 degrees? So we can use the information that tan of 45 degrees is equal to 1. So basically this 1 can be replaced with tan 45. So we would have tan of 45 degrees plus tan of 9 degrees divided by, now the important thing is this is tan of 9 degrees. So tan of 9 degrees can be written as tan of 9 degrees multiplied by 1. It does not change the value. So this would be tan of 45 degrees minus tan 9 degrees multiplied by tan 45 degrees. So this is of the format tan A plus tan B divided by tan 45 minus tan 9 times tan 45. So this does not actually fit in the question, correct? So if we solve this, tan of A plus B, we would get tan A plus tan B 1 minus tan A tan B, correct? So now, was this change required? No, because if we had tan 45 here, we can never get this format. So we can change this tan 45 back to 1. So our question would be tan 45 plus tan 9 degrees divided by 1 minus tan 9 degrees tan 45. Now this matches the formula of tan of A plus B, correct? So this is nothing but tan of 45 degree plus 9 degree, which is equal to tan of 54 degrees. So my suggestion is that you play around with these kind of problems, then you will get a knack of how we can actually approach this so that you don't have to struggle with these trigonometric questions. Thank you so much for watching. I'll see you in the next video.